Good morning, my dear students. My name is Anjani Sharma, working as physics lecturer in one of the reputed institution. Today, we are going to know a very important concept for all competitive exams about Coulomb's law. Okay? So today our concept is about Coulomb's law. So Charles Coulomb was one of the scientists found how to find force between 2 point charges. So charge means one kind of energy possessed by the body by losing or gaining electrons. So according to Coulomb, the force of attraction or repulsion between 2 point charges is proportional to product of charges. So let us consider 2 point charges, say Q1, Q2. Okay, separated by a distance R. Okay, so it is inversely proportional to square of distance of separation. So the second part of the Coulomb called Coulomb's inverse square law. Okay, so remember, force between 2 point charges according to Coulomb is directly proportional to product of charges and inversely proportional to square of distance of separation. So when you combine these two now, you get proportional to Q1 Q2 by R square. So F equated to a constant called proportionality constant, or you can call Coulomb's constant, into Q1 Q2 by R square. So you know where Q1 is charge on first body and Q2 is charge on second body. No, so this constant K naught taken as 1 by 4 pi epsilon naught. It is called permittivity of free space, means response of vacuum. So electric line of forces, electric force can travel through vacuum also. Okay, so this value, this total value is 9 into 10 power 9. Very important while you are solving problems now. So you must take this constant as 9 into 10 power 9. When epsilon naught, remember 8.85 into 10 power minus 12 units. It is Coulomb square now. So if you are taking this to this side, right? So epsilon naught is down now, Newton meter square per Coulomb square. You want epsilon naught, reverse now, means Coulomb square per Newton meter square, or its units. Okay, so this is the value of proportionality constant. Okay, so remember, force between 2 point charges. Okay, force between 2 point charges in free space, okay, is equal to 1 by 4 pi epsilon naught into Q1 Q2 by R square. Suppose the 2 point charges, okay, so the 2 point charges are separated by some medium. Say you kept some medium between the 2 point charges. You can keep glass plate or else an iron plate between the 2 point charges. So whenever 2 point charges are separated in free space, this is the formula you are using. But whenever in between them there is some medium is also taken, no, then force between them is 1 by K, okay, into 1 by 4 pi epsilon naught, okay, Q1 Q2 by R square. So this K is called dielectric constant, means response of the medium. So this effect of medium is also changing the resultant force. So remember, whenever 2 point charges are placed in air, this value will be taken 1. Suppose you place in any medium, it would be 1 by k into 1 by 4 pi epsilon naught q1 q2 by r square. Okay, r distance of separation and k is the medium that you have taken between the two plates. So how you define this? Permittivity of medium to permittivity of free space. Okay, permittivity of medium to permittivity of free space will give us dielectric constant. Ratio no, so no units. Okay, so remember, force between 2 point charges in any medium is given by 1 by k into 1 by 4 pi epsilon naught q1 q2 by r square. Okay, now let us suppose there are 2 point charges. Okay, so there are 2 point charges separated by a distance, say r1, medium say k1, okay, of dielectric constant k1. Say between the 2 point charges you have taken glass. Next, suppose the 2 point charges, same point charges, okay, are separated by some distance, say r2, constant k, k2. Earlier k1, now k2. Okay. Now, so you have taken 2 point charges, say q1, q2. Okay, separated by some distance r1. Dielectric constant, say k1. Next, same point charges, okay, placed or in another medium k2, okay, distance r2. Suppose if the force between them are equal, so force between q1 q2 when they are held in the medium k1 is equal to say k2 when they are at a distance r2. So different distances, different mediums, but according to the problem we are assuming that forces are equal. So force between the 2 point charges when they are in a medium of dielectric constant k1, it is 1 by k1 into 1 by 4 pi epsilon naught, right, q1 q2 by r square na. Second force, no, f2. Second medium k2 you have taken na, so k2 into constant 1 by 4 pi epsilon naught q1 q2 by r2 square. First one r1 square, second one r2 square. According to our problem we are assuming that the forces are equal. Okay, so whenever you are equating now these two, 1 by k1, right, into constant 1 by 4 pi epsilon naught, right, q1 q2 by r1 square, right, that is equal to 1 by k2 into 4 pi epsilon naught, okay, q1 q2 by r2 square. So constant terms are cancelled now. So k1 r1 square equal to k2 r2 square. No? So this is the condition when the forces are equal, when they are held in different medium at different distances. Okay? Now about limitation of Coulomb's law. So you already know force between 2 point charges we can find by using Coulomb's law. That is 1 by 4 pi epsilon naught, right? Q1, Q2 by R square. But whenever the charges are started moving, okay, so whenever charges are moving, okay, so whenever charges are moving, a moving charge is also capable of producing magnetic field. No, then force is due to electric and also magnetic, but we are finding only due to electric but not magnetic. So that is why force between 2-point charges is known only when the charges are at rest. So if charges are not moving, there is only electric field. If charges are moving, along with that magnetic field will also act now. So that is why, what is the limitation of Coulomb's law? Force between the 2-point charges you can find only when the charges are at rest. Now, let us assume the 2-point charges are in the beginning in air, next in some medium. Okay, so in the beginning they are in air, next they are in some other medium. Okay, so K1 R1 square equal to K2 R2 square now. So in the beginning they are in air, so dielectric constant value taken 1. Remember, whenever 2-point charges are held in air, K value taken 1. Suppose if they are separated by a good metal, then the dielectric constant value will become infinity. So for a metal, dielectric constant value is infinity. So in the beginning we are assuming they are in air now, so 1 into R naught square is equal to some medium, say K into R, okay, square. Therefore R square is equal to R naught square by K now, then R becomes R naught into root K. So this is the effective distance. Okay, suppose you have given a problem. There is one glass plate of thickness, say X. Okay, you have taken one glass plate, okay, of thickness X. Separation between them, say R. Okay, then this is the problem. Q1, Q2, you have taken a glass plate of thickness X. Separation between them is R now, so the remaining is R minus X, right? Now, you want to know force between them. So first you have to know the effective distance now. So effective distance is R into root K, no? So this case, dielectric constant K, no? So effective distance is, X into root K. Second part, R2 is equal to R minus X now into dielectric constant air, no? So that is why 1. Therefore, what is total distance of separation? X root K plus R minus X, right? Because the 2-point charges are separated by a glass plate of thickness X and dielectric constant K, no? So that is why the effective distance of this is X root K plus the remaining distance, R minus X into 1, right? Therefore, force between the 2-point charges, right, is given by 1 by 4 pi epsilon naught now into Q1 Q2, right, by square of distance of separation, that is nothing but X root K plus r minus x whole square. No? So this is a force between 2 point charges when they are separated by a glass slab of thickness x. Okay? There are 2 point charges. Okay? Separated by certain distance. Say force between them is F. Suppose if they brought together and again keeping it the same distance. So will there be any change in the force or not? So definitely there will be some change in the force. Why? Because you know, whenever you bring 2 point charges, no, so charge will move from higher to lower, higher potential to lower potential. This level of charging you call usually potential. So if one is having more electrons, the other is having less electrons. So whenever you bring them now, so electrons will transfer from one body to another body. How long it will transfer? Till both gains equal charge. That is nothing but you can say average charge. So this is the given question. There are 2 point charges, say Q1, Q2, separated by a distance R. So what is the earlier force between them? F. Right? So whenever you bring the point charges together, remember they gain average charge. So this is the initial force now. So 1 by 4 pi epsilon naught, right, into Q1 Q2 by R square. But whenever you bring them together and again keeping at same distance, constant wise no change because it is happening under same medium now. So distance is also same because you are keeping the 2 charged bodies at same distance, but they gain average charge when you bring them together. Or instead of bringing them, even if they are joined by a wire also, any conducting wire also, they gain average charge. That means each charge Q1 plus Q2 whole square, say equation 2. So this is the new force between them. No? Now divide second one by first one. Okay? Second one by first one. Okay. So you know this by this now common terms are cancelled. Right? You get Q1 plus Q2 by 2 whole square now by Q1 Q2. Right? So you get F dash by F is equal to Q1 plus Q2 whole square by 4 Q1 Q2. Or what is the new force between them? F dash is equal to, you can take Q1 plus Q2 whole square by 4 Q1 Q2 into F. So remember, whenever you bring 2 point charges together or 2 point charges are joined by a conducting wire, they gain average charge. Okay? So what is the new force between them? Q1 plus Q2 whole square by 4 Q1 Q2 of the initial force when they are separated by a distance r in air. Okay? Now about force experienced by a point charge. Okay, when 3 point charges are placed at 3 corners of an equilateral triangle of each side A units. So you want to know force experienced by any one of it due to the other 2. So here you are going to know force experienced by this due to the other 2. Okay, so you have taken 3 identical charges, say Q, Q, Q at 3 corners of an equilateral triangle of each side A units. Okay, so both are like charges now. So that is why force of repulsion outwards. This is also outwards. So 2 forces are acting on this. No? So according to parallelogram law of vectors, remember resultant force is equal to root over F1 square plus F2 square plus 2F1 F2 cos theta na. Charges are equal, distance of separation is also equal. No. So that is why F1 equated to F2, say some constant F. Equilateral triangle na. So angle, 60 degrees. Right? So resultant force is given by F square plus F square plus 2F square cos 60 na 1 by 2 cancelled, right? Root 3 F. No? So root 3 into F means force between any 2 point charges, right? So it is 1 by 4 pi epsilon naught. Identical now. So Q square by separation A na A square. So this is the resultant force experienced by this due to the other two. Suppose instead of positive you take one negative. Okay. Now you want to know the resultant force. Okay. So charge same, distance is also same. So that is why magnitude of the force remains same only, but direction changes because these two are like charges now. So that is why the direction of force is outwards, but these are unlike charges now. So that is why the direction of force is inwards. No, attraction. This one, repulsion. Now this total angle is 180. No, this is already 60. So the remaining is 120. No? So you want to know now the resultant force experienced by this due to these two. One positive and one negative. Okay. Now, so formula according to parallelogram law, F1 square plus F2 square plus 2F1 F2 cos theta. Now theta you have to take 120 degrees, right? Instead of 60. Why? Because in between these two attraction is there. So that is why the action of force is taken inwards. This one outwards. No? So cos 120 degrees value is minus 1 by 2 na. Therefore the resultant force, okay, is equal to root over F square plus F square minus F square. Cancelled, you get only F. That means force between them, 1 by 4 pi epsilon naught Q square by A square. So this is the resultant force experienced by this when one charge body is taken negative instead of positive. Now 4 point charges, each of magnitude say Q, are placed at 4 corners of a square of each side A units. Now you want to know force experienced by any one of it due to the other 3. Okay? Now let us suppose you want to know force experienced by this. Okay. This and this are acting on this at right angles now. Say this is F1 force. This is F2 force are acting on this at right angles. Right? So what is the resultant force of these two? Say this is 1, 2, 3. So now you want to find resultant force of 1 and 3 on 4. Okay. So according to parallelogram law of vectors, F1 square plus F2 square plus 2F1 F2 cos theta na. So F1 square plus F2 square plus 2 F1 F2 cos theta. So you know they are acting at right angles now. So theta is 90 degrees. And magnitude of force, if you notice, same. Because charges are identical, distance is also same. No? So resultant force of 1 and 3 on this is, you know, root over F square plus F square. Nothing but, you know, root 2 F. But at the same time, this is also acting on this. No? The action of force 2 is also acting on 4. No? So you want to know resultant force of 2 and 4. Okay? 2 and 4. Okay. So how to find the force between 2 point charges? You know, it is 1 by 4 pi epsilon naught na into Q1 Q2 identical no Q square by distance of separation. It is diagonal no, so diagonal distance, you know, side into root 2 na whole square. No, nothing but you can say 1 by 4 pi epsilon naught, right, Q square, okay, by A square into 1 by 2. Okay, so force between 2 point charges is F now, so it is F by 2. Okay, therefore the resultant force acting on this is, you know, root 2F plus F by 2, nothing but F of root 2 plus 1 by 2. Okay, so the resultant force experienced by this due to the other 3 identical charges is root 2 plus half into F. F means, you know, force between any 2 point charges. You can take different charges also. For example, you have taken different charge bodies. Okay, then how you find first action of these two? F1, F2 on this. No. Then you can find the resultant force. Okay. Next, force between these two. Say F3. Okay, force between these two is F3. So F3 is equal to, right? So charges are different, distance same, but charges are different. So force between this also you can find 1 by 4 pi epsilon naught, right? Say this is Q2, that is Q4 by separation. So you know diagonal distance A root 2 whole square. Here F1 and F2 you have to find separately. How you find F1? You know 1 by 4 pi epsilon naught, right? Q1 Q4 by separation A square. Okay. Next about these two, F3, 1 by 4 pi epsilon naught, right? Q2, Q4. This one now, Q3, Q4 by A square. Okay? So in this way, you can find first force between these two, then resultant force. Followed by addition of this. Will give you the force experienced by this part. Okay? That is when unidentical means if identical charges are given, you can use that formula. Other than identical, suppose different charges are given, in this way also you can solve the problem. Okay? Now, suppose there is one charge body of charge Q. So you want to divide this into certain ratio so that the force between them should become maximum. That is your question. In what ratio this charge body is to be divided so that force between them will become maximum. So let us assume small q charge is taken out from this q charge body. Therefore, the remaining charge will become q minus q now. So, according to Coulomb's law, force between 2 point charges is given by 1 by 4 pi epsilon naught q1 q2 now. Say charge on first one taken small q, remaining charge q minus q by r square. No? So according to problem, this force must be maximum with respect to the charge which is taken out, right? So this is all constant now. So you want to differentiate the force, no? Differentiating the force with respect to small q. So q into differential value of small q 1 na minus q square 2q, right? If this force is maximum, this differential value will become 0, no? So df maximum by dq is 0. That is when this force is maximum, differentiating with respect to q will become 0. That means this differential value, so q minus 2q is 0 now. So you can take 2q equal to q or q by 2. So what do you notice? If you divide this into two equal charge bodies, then force between them will become maximum. For example, you see you have given 100 Coulomb charge body. So in what ratio you have to divide? Equal ratio, 50 Coulomb, 50 Coulomb. Then force between them will become maximum. So remember, whenever you divide a charge body into two equal charges, 1:1 ratio, then only force between them will become maximum. Now about a neutral point. So neutral point means the point at which you place the charge body and does not experience any force. Suppose there are 2 point charges, say q1, q2, separated by a distance, say r. So in between you want to bring a charge body so that will not experience any force. So it is possible only when the 2 point charges pull this with equal force, no? So whenever they pull this charge body equally now, then the resultant force on this will become 0. Say suppose it is placed at some distance x, then the remaining distance will become r minus x. No? That means force between these two is equal to the other two. No. So force between 1 and 3 is equal to force between 3 and 2. How do you find force between 2 point charges? Nothing but Coulomb's law. So 1 by 4 pi epsilon naught, right, into q1 q3 by x square is equal to the other two now, into q3 q2 by distance of separation whole square. So common or cancelled, right? So you can take this to other side now. So r minus x by x whole square, okay, is equal to q2 by q1 now. Okay, so r minus x by x equal to root over q2 by q1. right? Or you can take r by x minus 1 equal to root over q2 by q1. Okay, you can take to other side, right? So you will get root over q2 by q1 plus 1. Or else you can take the distance, right? X is equal to, okay, x is equal to r by root over q2 by q1 plus 1. So this plus minus 1 depends on the nature of the charges. Okay, so if it is like charges, say positive, then it would be added. For unlike charges, the neutral point will be outside of these two. Okay, so if I am taking like charges, neutral point will be in between them. If you are taking unlike charges, it will be outside of these two. So instead of plus, you should use minus. Okay, for like, okay, plus. For unlike, minus. That means neutral point will be outside of these two, the line joining the two forces. Okay. Now we are going to know Coulomb's law in vector form. So let us suppose there are 2 point charges, say q1, q2. Okay. So which are at a distance from origin. One is r1, another one at a distance r2. Okay, so in vector form, let us suppose r1 bar, r2 bar. So in the plane, 2 point charges q1 and q2 are located at r1 and r2. Then you know the distance of separation r21 is equal to, you can take r2 bar minus r1 bar. No? So how you find force between 2 point charges? You know it is 1 by 4 pi epsilon naught, right? q1, q2 by distance of separation r21 whole square. So if you want to write in vector form, you know it is taken with a unit vector. So f bar is equal to, okay, 1 by 4 pi epsilon naught q1 q2 r21 cube na into r21 bar. Okay, so this is the force between these two. Suppose you are going to know from 1 to 2 with minus sign na, that means force between 1 to 2 is always equal to minus of force between 2 to 1. Nothing but you can say action, reaction, pair, Newton's third law. Now it follows Newton's third law. Now, suppose there are n point charges. Okay, q1, q2, q3 and so on, qn. Okay, or in the plane at r1, r2, r3 and so on, rn. Okay, so there are n point charges. Okay, q1, q2, q3 and so on at r1, r2, r3, r4 and so on, rn. Then the resultant force experienced by this due to all those n charges is nothing but, you know, vectorial sum na. So addition of f1 plus f2 plus f3 and so on will give you the resultant force. No? So force between these two, you know, according to Coulomb's law, 1 by 4 pi epsilon naught, right, q1 by r1 square. That is when you are taking it in the vector form, no, with a unit vector r1 cap, right, f2. So 1 by 4 pi epsilon naught q2, no, r2 square in a r2 direction, unit vector. No, next f3. and so on. Therefore, the total resultant force experienced by this due to all this is sum of these charges. Okay, so if you like this video, please subscribe, like, share. Okay, I am going to give you another part about Coulomb's second law, and in which we are going to solve more number of numericals. Okay, thank you.